Hello, everyone, and good morning, and many places in the world, probably good evening or good night. Uh, but what we are trying to do is we're continuing our weekly text meeting, and today many of our scientists group associates they are not able to be present, so I'm just going to briefly review and give a gist of what's going on uh, present. So last week, we had presentation of history of physics, the sixth episode, and we had myself and Christopher had a great discussions of ongoing things. And the sixth episode essentially is touching upon the fact that right now we have advances in physics, but there are a lot of questions, falsifications, even of general relativity and of even quantum mechanics. So people aren't sure, including Nobel laureates, that these physics are holding up. But there is a because especially mathematical theories like string theory does not have observables, so we need experimental verifications, and that's harder and harder, as we pointed out the last time. Uh, Classical physics had advantage that it was more scalar. We can actually measure them, and we use them like simple parameters like distance, time, speed, and the motion like expressed in terms of momentum, energy, and force, pressure. These are used in everyday life, and including classical thermodynamics, which uses temperature transformations and time. So these are all used even as a metallurgist. I find that these are all very common and fundamental aspects that we have to know to extract iron and steel and use for everyday life, uh, and including other metals and materials. So these are all aspects that we go on. But I also studied about the materials degradation, like corrosion and other aspects, which are all very real things. And we find that microstructure is also important. Like if we go into details about the crystallographic structure, it's very important that the most important part of material science is the crystal structure. And we believe that it could be true even at the smallest level, like the lattice quantum gravity that developed. But many of them, try to merge the quantum with the general relativity, because we still don't understand about the gravity, how it affects that originally Galileo talked about, and Newton did universal gravitation aspects, which still is holds good to understand about the heavenly bodies or astrophysical objects. Uh, so essentially, we are back to square one in some sense. So we try to solve ultraviolet catastrophe for classical physics in terms of quantum mechanics, but that start promulgated in vicious circle in terms of quantum vacuum catastrophe. Uh, so much difference in the theoretical value versus uh, you know, actual measurements. So we have a measurement problem which is expressed by many scientists, including Professor Smalling and others. But then we have Higgs field and other aspects that show that how the universe is, and we still many people believe the Big Bang, some kind of Big Bang occurred, creation of the universe, but that's again question. And my own theory, with Emmanuel and others, Christopher and John, Emery Taylor, discontinuum physics, and Manuel Malaver, astrophysical aspects, uh, as well as other scientists like Wen Song and uh, Andreas, Gerd, Christian. We all are advancing things that to how to reconcile between the theory and observations. So we have to always have physics that's closer to the experimental physics. So if you apply too much mathematics, that's the problem. So I believe in applied math. That's what I'm advancing, but also come up with algorithm. And I think eventually it has to be uh, stitched together as an IT thing. So I'm doing the IT developments of the physics. So IT quantum physics or the quantum astrophysics may be one of the ways we can go about doing that. So we need a path. I think this gives a path forward to understand the graphics, and then that, in some sense, justifies, because one of my original analysis with general transforms, including Fourier and all other transforms, together said that the universe is like a black box. Uh, and these are peer published papers that I have, more than 40, probably like 50 papers now. Each one of them is can be considered a breakthrough, and by itself a new advancement. It's not a repetition. Actually. So, so although it's only 50 papers, maybe a lot more than that. In actual aspects, if we we think about many other publications, it could be, as more than 100 papers in some sense. But the idea for us is not so much about the quantitative aspect of publications, but the qualitative aspects that all of us in our group believes in. So we may not have very scarce publications, but I think it's advancement that is to be really considered very seriously. Because one of the things I have come up with, the idea of the time itself is a wave function. So it's a wave function conda that each time you have so many possibilities. So the future, we don't know exactly why. One of the reasons is the time can occur as a tensor, which means that it's not a scalar. So you cannot measure. So it has to collapse, the tensor has to collapse. So how does it happen? One of my recent peer published papers, and that some things are in the Galilei proof region that which will be published, is that the first, the tensor aspect, have a gradation aspect and a matching of tensors between the gravity and time and everything, and that produces a vector, which is a rank one tensor. You can reduce to that, and even in IT field, these are used for data processing, things like that. Uh, but so we have then, processes going on at each time. So the future may be a tensor, time tensor, a wave function. Uh, it's like possibilities that's happening because of evolution of the events and things like that. And it's waiting for that tensor to reduce to rank one vector. And then we have, you know, many of them are ranked one tensor, like vector, like speed, like velocity, momentum, and so forth. And then the energetics work out. Finally, eventually, everything will collapse to one value based on the present. So the present advances to the future. So this is a new scenario that still we have to understand deeper aspects. But I see as a thought experiment that this is a very feasible and possible solution to the problem. Uh, and the gravity itself is only a gradient, it's not a force. So it interacts somehow with the time, and then it creates the real aspect, the scalar aspect that we can measure. So many people, recent publications show that it may be observable, the gravity, like graviton, that Emmanuel is deeply going into. The graviton and the bosons may have similar structure. It's only transformations between them. And we know the spin aspects are very important. Graviton has spin 2, then the bosons like photons have spin 1. And finally, they become fermions, which are like electrons that shows the current or the flow of things. So these are gradations that's happening in some sense. But the whole universe may be like a superluminal noisy, cogmer that's waiting each time by set of mechanism like hot PDP mechanism that we described locally, that the random processes locally create distorted fields that creates enough energy to create the hot PDP mechanism. There also you need high energies created, and this is like very similar. You can think of what happens in a electronic circuit, or ICs, or microprocessor semiconductors, that we apply a bias voltage, especially reverse bias voltage. Somehow we have a formation where everything comes together and the resonance occurs and creates very high amplification aspects. So this is very similar to how the Big Bang might have occurred, since that we may have isolated places of nucleation of these, what I call as the on particles to quasi particles. They are also called, you know, we introduced the term last time uh, as the plaquettes, or as a prion, like the prion model, for example, talks about the fact that they are subcomponents of quarks and you know other particles. So they are not really particles. So those are the stages, the transition stages that may be going through. Very similar to nucleation growth in materials. We studied in detail about how the nucleation occurs from a liquid phase, a molten state, into a solid state. Uh, so these processes are probably have connections, and mesoscopically we are seeing these. So they may have analogical aspects that we can utilize to understand the structure and how it develops. So we have a superfluid type of situation, and that from the superfluid occurs, creation of these particles, which produces a vacuum. It's a vacuum actually will be a dynamic aspect where the speed of light is constant, held constant. We can actually prove and mathematically that it can happen by the process requires that, and then that stabilization of the vacuum creates a stabilized fermionic structure, and the fermionic structure are very important to create real matter. So then the particles pop out of the vacuum and create, like, you can think of a general condensate aspect. So it creates subluminar particles that coagulate, and they steamroll into a real universe aspect. So those happens, you know, uh, the, the actual growth when they come together, it all happens all of a sudden, and we have creation like a big bang. So a very high energy aspect. It's a highly resonant frequency that reaches all of them come together like ensembles, and these ensembles then creates that highly amplified situation of wave function. And describing in terms of the signal, the fundamental aspect that we can measure from the universe is the signals, and we can we can find we had to find a unitarized way of handling that signal to noise ratio, so that we know the highest possible is 1 between 0 and 1. So we uniterize them and metricize them, so that we can measure them within the scope of uh, the instruments that we have. We can always. So measurement problem eventually could be solved by resorting to these aspects, mathematical aspect, which is more applied aspects, where I have described last time briefly, and I might I might point out some of the main uh, results, and Sorry that it may be a written thing. We are not yet published these things, but it's like um, copyright. I think we have, so I should be able to show what I showed last time. Let me pull up the. So essentially, what we have. Okay. So essentially, we have these type of believe that we get an output like that. We simply see some signals, and these signals then we process these signals that's coming on. We use they have signal as well as noise aspects in them. So we actually find the signals to noise ratio is the one that shows the energy content. So in order to find the energy content, we have to find the signal to noise ratio, and that's plotted here. And then we have an axis. This is a signal here, but a coordinate axis. This coordinate axis, we can see that these are essentially a space and time. But this space and time are not one dimensional. Even time is not one dimensional, as I said, the tensor. So there's a virtual dimension associated with that, and that I have developed as x to the power n, which x determines the type of spatial coordinate. N is the time of type of dimension. Similarly, for time, t to the power m, where the m again represents virtual dimension. So these are some of the math details, the minimal math details we have to go through, and we can find the tangent plane or the gradient of that, which is a very important even for even for any type of uh, analysis. We need this aspect because the tangent plane, for example, for time is a speed, the velocity, which gives velocity distribution that even Maxwell used eventually to prove about the electromagnetic, uh, transmissions or travels, or how the electromagnetic waves move in the form of light. So it's a very similar situation. Spectra, a very similar situation. So it's evolved from Maxwell equation as well as, but we need gauge field these days to actually uh, actually find the correct way of measurements. So uh, so this gradient will have certain you know Dirac type of Dirac delta type of functions where they go up very fast, and that may describe some of the aspects of the Big Bang type situations. So because the energy content, they can be directly converted or transformed to temperature. So they actually manifest as temperature, and we can measure them. So they can be called as a power density spectra and spatial and temporal aspects that you are considering. So in a way, if you do this, finally combining with the discontinuum aspects, where you have sinusoidal function, very nice sinusoidal function, could be a Citronov Bavay gun or cosmic microwave in some sense. But a cosmic microwave, let's say, is a sinusoidal wave in a simplistic representation. But then you have a gravitational wave that is interfering with that. So at some points, then you'll have perturbations. So you have carrier wave and a modulated wave. and that will be the fundamental. The radio signals normally have that. That's our radio astronomy, for example, will describe that. So we can mathematically convert it. I have done some mathematics here. Again, I had to work it out. But you have Fourier step functions, and also we can convert to the gradients of the tangent plane, the gradients of the vector field. And when I did that, you get a, very important uh, result, in the sense that we have, again, it's all written. So I just want to show you that I have this material when I'm describing, but it's not completely readable yet. But I just point out that use that and then use the temperature transform. We can show that uh, they the Fourier function of, or transform function of the signal to noise ratio, then in the limit, uh, the temperature in absolute value, so the temperature in kelvins goes to zero, or absolute zero we call it, the signal becomes one. So it's a superconductive situation we can get. Now we need to go through a lot of details, but I'm just giving a heads up of results that I'm getting. And when the temperature go to infinity, like I said, the Dirac function I mentioned, uh, then the signal to noise ratio goes to zero, which could determine the vacuum. So we have a situation, the endpoints of the universe could very well be between vacuum and superconductivity aspects. This is what I'm trying to point out. And mathematically, we can come up with that, but a lot more manipulation is necessary to actually describe the math uh, of what's going on. So I just want to give a brief overview of what it is, and we can mathematically prove that, probably because I said that the universe is a black box. So actual measurements may not be possible. Only mathematically we can measure some ultimate things, but then we can come up with variables, or parameters that we can actually measure. So those are measurements are simply cosmic microwave background and gravitational waves. So we develop the math, the applied math, to the level that we can compare with the cosmic microwave background and the gravitational wave based on these spectral analysis. Uh, and then we can see whether how they match together. So that's one way we can describe uh, a foolproof theory in some sense. So essentially, which means that all the aspects of the electronics, the semiconductor aspects, and all come into picture. So we have everywhere superluminal quanta, but then uh, by the simple process of the dynamics that's going on of the superfluids, they create these aspects. And Manuel Nobel laureates also mentioned about time crystal aspects and things like that, and also conformal quantum theories that that talks about these aspects, that we can have superluminal. And even Einstein equation doesn't totally, you know, exclude the aspects of superluminarity. So that's something we have to consider. And then, like Emmanuel pointed out, it could be gravitonic. And the fact that it's noisy and its tensor aspects means that they remain as dark. So that's a dark sector that we see, the dark energy, dark matter that we think the whole world is. That's because the tensor aspect is waiting to become scalar, to really become measurable uh, in a real sense. So until then, it is dark. But every time the future goes, that dark aspect become light aspects. So we get the photons and all the four super forces that we think in terms of the electromagnetism, gravity, uh, the strong nuclear and the weak nuclear. There may be a fifth force as well. Many people think it's quite possible where the coupling really happens between all these forces in some sense. And so altogether, then we see that these processes have certain mechanisms, and these mechanisms are the one that is holding back. Even Higgs mechanism was one of the aspects that is you know advanced by many of the top scientists, physicists. So certain mechanisms and the mechanisms automatically require a time frame. So they have each particle that creates have uh, the spin and aspects going on to create the right conditions to collapse to real particles and also real matter universe. So the environment is fully charged, and then we see these phases in the real world that we have we have gases, we have plasma. It starts with plasma. You can say the stars, plasmatic, high temperature ionic phases. Then the plasma then become cools down to gases. That happens in star system, like even our sun, and then uh, eventually cools down enough to create fluid aspects. So that fluid aspect then translates to liquids like water in certain places. We think right now Earth may be the Goldilocks aspect where these things happen, but there could be other places. It doesn't preclude any other place in the world to have similar situation. Although we have not yet found complete evidence for that, but uh, there are clues and hints that followed with the moon's mission, the Mars mission, and also the alien Earth mission, Earth measurements with the advanced telescopes that we have in James Webb and Planck and Einstein and Chandra and all that. Many different telescopes. The radio astronomy is pointing out the possibilities that even life could have occurred in other places on Earth, other than just our own planet Earth. So, which means that the liquid, but it could be at different stages of the phases. But the liquid eventually has to the liquid phase of the planets eventually have to become solid phases, and we go through. We said the nucleation growth processes. For example, the center of the Earth, we have magma, hot liquid, which has a lot of magnetic aspects, the electric aspects. They churn together to produce, we cool down rocks and all that, different rocks. So we have insulating layers that you know we have interfaces that separates, like very similar to vacuum that we described, that separates from the superluminal phase or subluminal phase, and also eventually the liquid phase and the solid phase, so that the solid phase become stable. So then we have rocks, and from there we have formation of you know flora and fauna, so to say, of maybe like grassy situations or from marshlands to grassy situations, and that creates enough to create enough oxygen and things like that, and the trees then essentially uses the uh, what you call photosynthesis aspect with light interactions and creates actual life process, the fruits and other things. So the it could have been the trees come into picture and that flowering, then eventually that creates with viruses and bacteria the actual real lives, single cell organisms to multi-cell organisms that we are. Eventually the animal kingdom occurred continuously, and the genetics essentially proves this kind of theories that we evolved from there. from the Homo erectus and the Homo sapiens. We became, I mean, we evolved into Homo sapiens, and that's what humans are. Then we have the consciousness, which is one aspect that all the scientists are trying to describe what exactly is. It's related to physics. So the connection between metaphysics and physics, and our advancements in the scriptures and all the religions, essentially, tells the other side of the story, which is not, you know, rational or logical in that sense completely. But we see ourselves evolve from higher, powers. We call them gods, and also the fact that they have special abilities. And then when we came here, we became humans, but consciously we understand them. So we have a body, mind, and soul, uh, that we believe that the mind has the power, like the wave function. So mind may be a wave function in that sense, and the body may be the real, scalar aspects that evolves out of that. And then we have the superluminal thing, which is soul. So the connection between metaphysics and physics is becoming closer and closer, and it's merging, and the imaginary is merging with the real. In that sense, if we think continuous thought processes, but where mathematics helps in the twining or the stitching aspect, the string theory that is very simple in the concept in terms of the you know open strings and closed strings, but how they create strong forces is we need powerful things like Gell-Mann matrices that talks about the octets, things like that, to form the strong aspects. So it's essentially a compression process that could be. So you have diluted aspects and highly compressed, uh, you know, aspects. Uh, so this may be what's happening in the universe. So you see a dilution effect as well as coming together concentration aspect that eventually concentrate to a level. As we know, the black hole theory essentially talks about that, the crunch that occurs because of gravitation. We call them as the gravitational effect, but that could be the vortexing aspects of this. We believe in the fundamental sense, a vortexing mechanism that creates that. And then we have the transfer. That's the transverse waves, and the longitudinal waves are spreading out as like open strings. Uh, so the vortexing and also the 0 point aspects may be the most fundamental aspect. So that's the fundamental matrix, that 2 by 2 matrix that we talked about from the Helmholtz decomposition aspect that originally I published along with Emmanuel, the theory of the quanta. Uh, so, and from there, we could actually advance that I had, especially as advanced mathematically to the level of time wave functions. And that seems to be, a step by step aspect to be holding good. And we can describe the past, present, and future history. And it's very important, the history of physics series episode is so important because we just follow without any speculation how it actually developed. So the physics develops by own, but it goes through crises, things like that. There are many philosophers, including Popper and Krag and uh, you know uh, others have described, especially the tools that you know happen that helps to consolidate the physical aspects. Cartwright, for example, talks about the tool aspects of the physics that we have instrumentation also had to be developed to measure them. So now LHC is the fundamental microscope or the particle microscope of the quanta that's describing the micro world. But the macro world is described by the telescope measurements, and the telescopes are also getting more and more sophisticated to measure all different signals that we get. So we have now a micro world and macro world or astronomical world, and then we are in between the mesoscopic world. So we have both the effects, like I mentioned, my peer reviewed papers that the time effects may be hidden in the quantum level as well as astrophysical level, whereas the mesoscopic level, both the time and space come together. So that's why the space-time aspects be uh, different, collapsing of the time wave function and the gravity gradients that creates our real universe. So these are something that is we can really advance, so we can make sense. We can also resort to common sense because a common sense level, we also are probing the real aspects of the world. So we see the way it is, the night sky, for example, and we see the stars as points of light, and then we planets does not have this brightness. So that's the original way we developed as humans, from the human point of view of eye, and we extended eye to a telescope aspects, which go into details. But on the other hand, we see an inner world, a microscopic world. This way, like with Emery, the realities, how we see, how the mind sees, the time may be like that. So there's the idea of matrix simulation aspects that that everything is a matrix. So finally, I'm categorizing everything into what we call the two by two aspect, the two by two matrix of the matrix, the entity. So we can clarify in terms of matrix, in terms of entity, in terms of vacuum, in terms of quanta. So we are part of the quanta, for example. So I'm defining each one, and we can have a set of values that each one has. That some of them are can be classified as matrix, some of them can be classified entity, for example, particles, the specs, for even photons and phonons. Then we have vacuum, where the speed of light is constant, but vacuum may not be empty, like many people are saying. And then quanta, because of that, quanta comes to picture, and we are part of the quanta because both wave and the particle aspects come into picture. So the matrix, as well as the entity come to picture. This is why the idea of M theory with the brains may make sense, and that's an advancement we are making. The brains itself talks about you talk about a flat universe where the brain will have essentially you know the supraluminal, but at the same time like a vacuum aspects I talked about, it does not have much vortexing aspect. Essentially like a 0 point fields occurring in that vacuum. But then we have vortexing aspect, we make it to conda, and the brains themselves start to curve. So, and then that curving creates the gravitational effect. Eventually, with the both the flat brains as well as the curved brains, so to say, they create a curled up dimensions that we see all the way to cell mechanisms. If you look at the structure of the cell, we have curled up aspects. That's the most important aspect for existence. And the consciousness may be coming out of these curled up dimensions because they can have information content inside them that helps them to create true feedback mechanism, intelligence, and all that to understand the rest of it. So this is a complex aspect of the nature and very fantastic and exotic aspects that something that we have to understand more, and that puts together. It seems to be coalescing into a reasonable understanding of how the world works, how everything may be part of this larger system, but the smaller system may be part of the larger system. But we could have a smaller system also engraping the larger system. So this is the highly interactive aspect that makes highly complex that we understand because we understand the sea. We see the sea just waves coming up, but we go into the sea. There's more life under the sea inside the like Atlantic Ocean, Pacific Ocean than even on Earth. So it tells us that there is something beyond that our normal senses can figure out. And that's the extension that we use other instruments to figure out. Uh, and that's part of the measurement aspect. Measurements may have different phases. And so we have to transition and that we always will have doubt about that because we can it can give a wrong you know output. A lot of times we see that what we see we can we can be fooled easily, right? What we hear we think that is and then that's not what it is there. So it can have a lot of furious or spurious aspects, spuriousness, uh, and like Einstein has spooky action, things like that. But realistically, we think that even quantum superposition and quantum entanglement is a realistic possibility. But you have to put in the right context. Then I think the general relativity and quantum physics, everything will come together with a higher theory that we think is a discontinuum uh, physics, but with discontinuum quanta astrophysics. Uh, that may be one of the ways we can think about the whole aspects of the universe. So with this, I like to finish this particular video. It's just to give a brief overview of what's going on and quite a cohesive aspect in some sense of what we understand today, and that makes sense to proceed in the right direction. So that was the biggest aspect, how to go, what direction to go. I think now we have that direction, and our project physics is going, although slowly but steadily, into the real understanding of how the world could have come into picture, and then hopefully a grand theory of everything, a theory of everything with a grand physics could be there up in the corner in the future to come. Thank you very much, and